Welcome to qnawire.
This question is applying Gauss's law using volume charge density that is different in different regions. Okay, so we are given the volume charge density. Okay, so it is 3 alpha r divided by 2 big R for r less than or equal to r over 2, and then alpha times 1 minus r over big R square, at for r over 2, between r over 2 to r, and then 0 for r greater than the radius. Okay, all right, so in this question there are 4 parts. Okay, so in part A we want to find the total charge, so that the total charge is q. Okay, a positive charge q, and then we want to determine alpha in terms of q and r. Okay, so solution. Okay, so q is equal to rho dv, and then so we have two charge density, so we expect to integrate in two regions. 3 alpha r divided by 2 big R times 4 pi r square dr plus from r over 2 to big R alpha 1 minus small r divided by radius square, and then 4 pi r square dr. Okay, so because this is a spherical charge distribution, so the dv will be 4 pi r square dr. Okay, so then for the first one we can pull out the constants. Okay, and then we are left with 0 to r over 2 r cubed dr, and then we do the same thing for the second integral. Okay, then continue. 3 alpha divided by r times 2 pi, and then you get 1 over 4 r over 2 to the 4. Okay, yeah, so when you integrate r cubed, you get 1 over 4 r to the 4, and then you put in the limits. The only limit that contributes to the definite integral is the one with r over 2, so you can just substitute like that. Okay, and then you do the same thing for the next term. Okay, then so you can simplify the terms in front, so you get 3 alpha pi divided by 32 big R cubed plus 4 pi alpha 1/3 R cubed minus R over 2 cubed minus 4 pi alpha divided by 5 R squared 1 R to the 5 minus R to the 5 divided by 2 to the 5. Okay. Okay, so continue to do 3 alpha pi divided by 32 r cubed plus 4 pi alpha, okay, times 1 over 24 r cubed minus 4 pi alpha divided by 5, 31 over 32 r cubed. Okay. Oh, here is a 7. Okay. Okay, so you continue to do, and then you get now you can actually, because the pi alpha and r cube are constants, pi alpha r cube, okay, they are constants, you can pull it out. So you have 3 over 32 plus 7 over 6 plus minus, okay, minus 31 divided by 40. Okay, so if you do this, okay, then you get 233 divided by 480 pi alpha r cube. Okay, so alpha is equal to 480 q divided by 233 pi r cube. Okay, so this will be the answer for part A. Okay, then in part B, okay, we need to use Gauss's law to find the electric field in 3 regions. Okay, and express your answers in terms of total charge Q. Okay, so there are 3 regions that we are dealing with. So first we deal with the inner region for R less than or equal to R over 2. Okay, Gauss's law says the surface integral E dot dA equals to charge enclosed divided by epsilon naught. Okay, so the left hand side will always be E times 4 pi r square, okay, because of spherical symmetry. Okay, and the E will be the same from the center. Okay, the magnitude of E will be the same from the center. And then the next task will be to find charge enclosed. Okay, so the charge enclosed will be from 0 to small r rho dV, but we are only interested in the region with 3 alpha r divided by 2r. Okay, this charge density only, because it's between 0 to r over 2. Okay. Okay, so if you do this, you have 3 alpha over 2 r, and then times 4 pi, and then times integral of r cubed dr. Okay, so if you simplify, you get 3 over r times 2 pi. Now you can actually substitute alpha 480 q divided by 233 pi r cubed, and then you have 1 over 4 r to the 4. Okay. Alright, so this is the 1 over 4 r to the 4 is the integration, and then the 3 over r times 2 pi is when you simplify the 3 over 2 r times 4 pi. Okay, and then I also put the alpha inside here. Okay. Okay, so if you simplify this, okay, you get 720 divided by 233 q r small r to the 4 divided by big R to the 4. Okay, so E times 4 pi r square is equal to 720 divided by 233 q r4 divided by big R to the 4. Okay, and then 1 over epsilon naught. Okay, so then you have our q over 4 pi epsilon naught r to the 4 and then you have our 720 divided by 233 r square. Okay. Oh, yeah. So if you want to simplify further, okay, then you can divide the 720 divided by 4. So you have 180 divided by 233 q over pi epsilon naught uh, r to the 4 times r square. Okay. Yeah. So this is the electric field uh, inside the first region. Okay. Okay. So this is our E field in the first region. Now we want to do the E field in the second region. Okay, so for R over 2, for the region between R over 2 to big R. Okay, so just to remind you all, so this is the spherical charge distribution to radius R. Okay, and then we have two regions. So this is row 1, this is row 2. And then now we are looking at the Gaussian surface at this in this green circle. That's the that's the Gaussian surface that we are considering for the region between half R to R. Okay, so the charge enclosed, okay, will be there are two things that we need to consider. Okay, so one is the charge in the first region. So 3 alpha r divided by 2r times 4 pi r square dr. Okay, and then plus the second region, r over 2 to small r alpha 1 minus r square divided by, okay, and then 4 pi r square dr. Okay, so there are two regions that we need to consider. So the first one, if you do the integration, so you have 3 alpha over 2r times 4 pi, and then you have 1 over 4 times r over 2 to the 4. Okay, and then for the second term, you get 4 pi alpha okay, when you integrate, you get r cubed divided by 3 minus r5 to the divided by 5 r square and r over 2 to small r. Okay, so the first term you get 3 over 32 alpha pi r cubed plus, and then 4 pi alpha 1/3 r cubed minus 1 over 5 r square r to the 5 minus 1/3 r over 2 cubed plus 1 over 5 r square r over 2 to the 5. Okay, so just continue the algebra. Okay, 3 over 32 alpha pi r cubed plus 4 pi alpha. So you can start to group the terms with the big R. Okay, so here I have 1/3 r cubed minus r to the 5 divided by 5 big R square minus 17 big R cubed divided by 480. Okay, and you can start to include um, the okay, I'm going to put the alpha later. Okay, so 3 over 128, I'm going to insert 4 pi here. Okay, right, so okay, I'm going to do Gauss's law. E times 4 pi r square equals to charge enclosed divided by epsilon naught, so 1 over epsilon naught. Okay, so notice that there are 4 pi from the charge enclosed, which I'm going to pull out. Then I have 3 over 128 alpha r cubed plus alpha 1/3 r cubed minus okay. Okay, so the next thing I can cancel the 4 pi, and then I'm going to put e in this way. 1 over epsilon naught r square. I'm going to pull out the alpha. So alpha is equal to 480 q divided by 233 pi r cube. Okay, and then I have 3 over 128. Okay, I'm going to combine the 3 over 128 with the 17 or over 1 over 480. Okay, so okay, this is what I'm going to do. Okay, so 1/3 r cube minus 1 over 5 r5 divided by r square, and then minus 23 over 1920 r cube. Okay, okay, next so 480 divided by 233 q over pi epsilon naught r square 1/3 r divided by big R cube minus 1 over 5 r divided by big R to the 5 minus 23 over 1920. Okay, so this will be the E field in the second region. Okay, okay. Next, for the region that is outside, for r greater than the radius of the sphere, so the charge enclosed is just q. Okay, so E will just be q over 4 pi epsilon naught r square. Okay, this is the E field for region outside the radius. Okay, then now we move on to part C. In part C, what fraction of the total charge is contained within the region r over 2, between r over 2 to big R. Okay, oh, there are 5 parts. Okay, never mind. Okay, so fraction is equal to okay, so this fraction is 47 divided by 120 divided by 233 divided by 480. Okay, so you get 188 divided by 233. This is equal to 0.807. Okay, so how do I get this answer? It's actually from part A. Okay, so yeah, in part A we have if you go back to part A, okay, go up, go up, go up, 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 up. Okay, so in part A, this term is a contribution from the R over 2 to R, right? So if you actually combine this 7 over 6 minus 31 over 40, you get 47 divided by 120. Okay, and then this is the total. This is the total, right? So that's why when I'm asked to find a fraction of the total charge in part C, right, is 47 divided by 120 here divided by 233 over 480. Okay, yeah, so that's how the numbers are obtained. Okay, so this is refer to part A. Okay, later. Okay, so the answer for part C, 0.807. Okay, in part D, we want to find the magnitude of E at R equals to half of the radius. Okay, so we'll go back to refer. You use this expression. Okay. Okay, so at R, at half of the radius, okay, the electric field is 180 Q divided by 233 pi epsilon naught R to the 4 times R over 2 to the 4 square, sorry. Okay, you get 45 over 233 Q over pi epsilon naught R square. Okay, so this is the answer for part D. Okay, then in part E, we want to explain why that the force, if we release an electron at any point in the three regions, the resulting motion is oscillatory but not simple harmonic. Okay, so yeah, so for simple harmonic motion, okay, the force needs to be proportional to minus R. Okay, but in this case we don't have that kind of relationship. Okay, it is oscillatory. Since the force is always attractive, but it has the wrong power of R to be simple harmonic motion. Okay, so yeah, we just don't have this kind of relationship. Okay, don't have this kind of relationship. Okay, yeah, oscillatory because it's attractive. Okay, and so that's how we explain part E. Okay, and that's all for this question.